1, 2, 2, 2, 2. Alrighty. So first one says fill in the blanks so that the resultant statement is true. If t is a real number and p equals xy is a point on the unit circle, then t that corresponds to t, then x equals the blank of t and y equals the blank of t. All right, so what this is referring to is when we learned about wrapping a number line around the unit circle. All right, so if we were to take this number line here and wrap it around this unit circle, okay, wherever these different values landed, like pi over 6 and pi over 4 and pi over 3, those landed on these dots here. And so the x and the y coordinates represent the cosine and the sine of whatever these values are. So wherever pi over 6 lands, when you wrap it around, okay, that's going to be the sine value. So this would be the sine, and the other one would be your cosine. I'm sorry, the x is the cosine, and your y is your sine. So choice 1 and choice 2. Okay. Yeah, this is review 2. It doesn't. Does your guys look different? Does the other folks, does your review look like this? When you opened it up? Is that the first question? Oh, okay. All right. So you're looking at you're opening up the one in Math Excel. Okay. All right. Okay, so now the next one says point P shown on the unit circle corresponds to the real number T. That's just like what remember, all we're talking about is taking a line and bending it around the unit circle. And when you have a point on that line and it lands on the unit circle, you can describe its location using an X and a Y, just like you would locate something on a grid using X and Y. All right, so the question is, find the values of the trig functions for this particular point. All right, so on your paper, what I would do is I'd just make a quick sketch of this and label it. So we already did one, okay. So for one, I'd say on the unit circle, X, Y, X is the cosine, and Y is the sine. Okay, so then for part 2, we're going to make that sketch, right, and figure out what the 6 different ratios are. So now it's going to ask you what are the different sines, cosines, and tangents. So sine, or let's see, what's it start with, sine or cosine? Sine. Okay. So we know the sine is the y coordinate. Okay, so sine is going to equal 18 over 17. Cosine, negative 15 over 17. Okay, and now tangent. All right, tangent is sine over cosine. So 8 over 17 is my numerator, and negative 15 over 17 is my denominator. I end up with negative 8/15. Okay, and then you had to do the reciprocal. So the reciprocal of sine is cosecant. So we flip that. Okay, reciprocal of cosine, secant. It's still negative, we just flip it. And then reciprocal of tangent, cotangent. That would be negative 15/8. Okay, so type those in. So when it says it corresponds to the different values of t, and t is pi/6, pi/4, and pi/3, that's these dots right here. And then your sine and your cosine are just the x and the y coordinates. Your x is cosine. So even when you're looking at your unit circle, guys, it's labeled. X is labeled with cosine and the y is labeled with sine. Function at the indicated real number t. State the expression or state the expression as undefined. So if there isn't a sine or a cosine, if it's undefined, which that doesn't happen, then you would say undefined. All right, so number 4 is pi/6. So here's our pi/6. All right, and the cosine of that is going to be √3/2. So I'm just using my unit circle again. √3/2. Okay, number 5. Find the exact value of the expression. So you're going to go to your unit circle. You're going to get what this value is. You're going to get this value, and then you're going to multiply those two answers out. Okay, cosine 60, cosine 30. Go to 30, which is pi/6, and the cosine is √3/2. Okay, now we multiply those straight out. Okay, √3 times √3, that is 3 when you multiply a radical by itself, and then 2 times 2 is 4. So my answer is 3/4. We're going to change the radian into degrees. It's 38 degrees. And then just hit enter. Now you can just type in the question, which is the sine of 38 degrees. So sine 38, close the parentheses. And I'd say round it to 2 decimal places. Okay, so this would be 0.615. So if I'm rounding it to 2 decimal places, I'm going to look at the 5, and it tells me to round the 1 up. Okay, now on the next question, this is in radians. So on this one, we wanted the mode to be in degrees. And on the next one, it's asking you about the sine of 4 pi over 15. So now you got to switch the mode to radians. So now underneath that, make a little note, mode. Okay, and I want to be in rads now. Mode. Switch it to radians. And now I can just type that in. Quit. Sine 4 pi divided by 15. And then divide that, or round that to 2 places. So 0.743 rounded. Took 8/10 and I wrapped it around the unit circle. I just bent it around the unit circle. And so it's on the 8th tick mark here. Now what you want to do is to get the coordinates, to get this cosine and the sine, 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right, that's our mark. Now you want it to get the sine and the cosine and the tangent and all that good stuff. You've got to find the x. This would be the y coordinate of that dot, and this is going to be the x coordinate. So you go over here, and if I said, what's the coordinates of that dot there? Okay, well, let's see. If I go from the 8th dot and I drop a line down, that's going to give me my x coordinate. So the x is 0.1, 2, 3, 4, 5, 6, 7. That is 0.7. Okay, 0.7. And then the y coordinate, go across. And that's at 1, 2, 3, 4, 5, 6, 7. So that's at 0.7. All right, so now once we got that, we can list what all these things are. Okay, so this is number 8. Okay, so the coordinates of my point are 0.7 and 0.7. This is the x and this is the y. Okay, so for that problem, write down the coordinates of your point. Okay, now it's just like this. Okay, the x coordinate is your cosine and the y coordinate is your sine. Right? All right, so as you're filling these in, sine of the angle, or excuse me, sine of 0.8 is 0.7. Okay, the cosine 0.8 is the x coordinate 0.7. Remember, this is your cosine, this is your sine. Okay, and then the tangent of when you wrap 8/10 around is 0.7 over 0.7. So that is 1. Okay, now to get the reciprocals, right, you're going to go the cosecant. All right, now to get the reciprocal of 0.7, all right, think of 0.7 as 7/10. So when I flip 7/10, it becomes 10/7. And the tangent or the cotangent is going to be 1. Okay, and I think you got to type decimals in for these. So I'm just going to convert those. 10 divided by 7. And does it say what to round it to? To the nearest tenth. Okay. This would be 1.428. And if I rounded mine to the nearest tenth, it's about 1.4. All right, so that's what you're doing for the first part of that here, where you're just filling these in. And then you do the exact same thing on your calculator. Now you're going to do the same values on the calculator and round it to the nearest hundredth. Okay, so I'm just going to repeat this, but using my calculator to do it. All right, now here's the question. When you're doing it on your calculator, are you in radians or are you in degrees? Which one, guys? To Corey, radians or degrees? Pardon me? Yeah, it's asking you, we estimated using the drawing. And now we're repeating, now it's the bottom half of this is to do it using your calculator. So the question is, is your calculator gonna be set in radians or degrees? Radians, okay? So keep in mind on this question, this is gonna be, make sure your mode is radians. And now it's just a matter of typing it in and rounding it to 2 decimal places. Okay, so I'm gonna set my calculator at rads. So I go mode, radians, it's highlighted, so I'm good to go. All right, and my first one is going to be sine 0.8 radians, and I get 0.717. All right, so 0.717, so that's going to round to 0.72. Okay, now, if I want to get the reciprocal of that, guys, on my calculator, all right, to get the reciprocal, you see that, look, if you look at this key right there, it's got the -1 on it. Let's see, x to the -1. Okay, that's the reciprocal. Or you can do this. You can go 1 divided by your answer, second answer, and that's the reciprocal. So if I flip this decimal, I would get this. So that to two decimal places is 0.39. Now the rest of it we can all fill in, because since these were the same, these are going to be the same. Okay, these two were the same. So these two are the same. And then these were 1. This one down. It says, given a point, the point below is on the terminal side of an angle in standard position. Find the exact value of the 6 trig ratios. So your point is 24, -7. All right. So on your reference sheet, okay, I want you to find the page that looks like it's this page right here. So where it says unit circle, that's what you're using here. All right, so let's copy this down over here. So number 9. Okay, you've got the coordinates 24, -7. And we've got to find all 6 ratios. Yep. All right. All right, and 24, -7, that is going to be in the 4th quadrant. Because X is positive, Y is negative. So I'm just going to pick a point in the 4th quadrant. And my angle opens like that. And that has the point 24, -7. So you sketch that. All right, and now once you got that sketched, you're going to create a little right triangle here. So I'm going to, from that point, that's a right triangle. This length, this is 24, and this leg is -7. Now, the length of the leg, guys, is actually a positive number. The negative just means it's facing down instead of facing up. All right, now let's get what the radius is. So that's when we use the Pythagorean theorem. All right, so I can get the radius by the radius squared equals 24 squared plus -7 squared. Okay, so mine 24 squared plus -7 7 squared. Now notice how I put -7 in parentheses? If you just put in -7 squared, it won't do it correctly. It's got to be in parentheses. So it's -7 times -7. Okay, that's 625, and now I'm going to do the square root of that. Second square root, 625, and that's 25. So the radius here is 25. All right, so what you're dealing with a circle whose radius is not 1. Our radius was 25. Okay, so in this case, we're dealing with this situation right here. All right. All right, so to get our sine and our cosine and our tangent, we're going to use these values, except now sine is equal to not just the y coordinate, it's y over r. Cosine is x over r. And then tangent is going to be y over x. Okay, and I'm just taking those right from this chart up here. Okay, so what I would do on my reference sheet is on the reference sheet, I'd go to this slide, and underneath this unit circle, I would copy these down. So, reference sheet. So right here, I would write that sine of theta is y over r, cosine x over r, tangent. So I'm copying this down, the exact same thing. Okay, tangent is going to be y over x. Okay, cosecant, flip that one. Secant, flip cotangent, flip. You want them to have the r's on it. This one, we didn't have to worry about r because r was equal to 1. So y over 1 is just y. Doesn't affect it. All right, so sine theta is going to be the y coordinate, which is -7 over the hypotenuse. So -7 over 25. Cosine x over r. Oh, yeah, x is 24 over 25. Tangent is y over x. 7 over 24. And then you flip those to get your other ones. So cosecant is r over y. Secant r over x. And then finally, cotangent is a negative 24 over 7. And that's the second review as well, okay? And that way we can go over the answers to 3 and 4 tomorrow. And I'll put a video up of review 3 by the end of the day, probably like around by 4 o'clock.